Yo, what's up, everyone? Welcome to week 71 of Chill Kernel Hacking for Fun. Um, Thanks for joining. If you're here for the first time and watching the recording, I would recommend skipping to the end of this video, where I'll probably just do a bit of a recap of how the stream went. But yeah, I'm doing a little bit of a non-standard thing today. Because it's Saturday and I usually stream on Sundays, so just give me a moment to send out a tweet and do all my usual stuff. Send a ping in the Discord. Yeah, so today I'm planning to work more on booting with grub. And let's see, last time we made some good progress on that. We got grub booting working, but we were using the multiboot version 1 specification. And today I want to upgrade and use multiboot version 2 and adapt the OS to use that version, because it's kind of the current state of the art as far as multi-boot, and so it's good to be on a more recent version of that standard. It's also more powerful, I think, and has a lot of good advantages. So let me hit publish on this tweet. Publish now. I'm gonna do my usual test 0 in the chat. What's up, Krishna? Thanks for joining. Nice to see you. What's up, DG or Jew? Welcome to the stream. Krishna, was it, did you leave that comment on that video this week, kind of helping me debug that, that problem with the memory mapping and stuff? I think that was you, right? Yeah, appreciate that comment. All right, I want to be a bit better about watching the Twitch chat. Yes, my status is 14. All right. So I'm gonna So I'm just getting things set up on my end, monitoring the stream health and whatnot. Craig, one day I'll match your current video. Oh, I see. You're on stream 14 out of what, 70 or something like this. Well, yeah, no rush. Yeah, but I don't know. Those older streams are kind of boring anyway, so. Yeah. Yeah, so today we're working on the boot process. We're getting back to booting, so let me... yeah. All right, let's just kind of slowly get into it. Actually, I'm going to close my window because I think it's kind of noisy outside. Super quick test of soundboard. You know, just in case we need some sound effects today. All right, so just checking in. What does our Git look like? I just have a couple lingering changes. Okay. This is probably the more interesting one. And so this is just a bit of a lingering change. I like last time I needed to like build the kernel and then run this grub image thing. And then now I've linked it up so that automatically the grub image will get built if the kernel changes. So that's just a bit of a nicer workflow. So add kernel, build automatically. What's up, John? Nice to see you. Yeah, a bit of a surprise. I think first ever Saturday stream for me, but I just like can't do it tomorrow. And I was kind of thinking like, usually I just pre-record the stream by myself and then like queue it for like an upload on YouTube. But I don't know, that's kind of a bummer because people don't really watch that. It's not as enjoyable to join. And so I was like, okay, I'm just gonna stream. Cool. Yeah, what are you working on? Doing some OS stuff too this morning? What is it? Today's Saturday, right? Yeah. So this is, yeah. What was I even doing? I think I was just sketching out some random BS here. This is also not super important. Maybe I will just amend this into there. Okay. So right, multiboot v2. So this will be hopefully pretty fun. We'll be able to write a bunch of C code today, and my goal will be to port the OS from using multiboot v1, which is basically, oh, I don't even have a text editor open right now. That is huge. Why is the text so big? Okay. As you can see, I was reading the grub source. So multiboot v1. Multiboot v1 is like this thing. That's where the bootloader passes you, or passes the kernel a pointer to a structure with a bunch of useful information that the OS can use. And it's just this like kind of big struct with a bunch of stuff in it. Turns out there's a lot of problems with multiboot v1, and they made a new standard that's not compatible. And one of the problems is that this is not extensible as I understand it. If you want to add new stuff, it's just this big struct, and so it's not great for extensibility and compatibility. So they've changed some things. I have these panics here. Maybe I will just actually keep the panic in just for the moment. Yeah, all right. I'm just checking Twitter just to make sure my tweet went out correctly. All right. One viewer on Twitch still. I think that's just me. Yeah, I went to TwitchCon last week in Amsterdam, which was awesome. It was really cool to just connect with some other streamers and talk shop. Not a lot of other programmer streamers there, but I did meet the Primogen, which is pretty cool. Okay, so multiboot v2. How do we begin? Maybe I'll just search for multiboot v2 and give a spec. Today is June 7th, and we're doing stream 71. I'll just paste the link here, and it would be dope if I could get a PDF of this. V2. Got my documentation, open the system viewer. All right, multiboot V2. This will probably be good to have around. What's up, Digitalized? What's up, Bacon? Yeah, surprise stream. Figured it'd be a bit nicer because I can't do it tomorrow. So just take the opportunity to do it right now. Oh, hi, Bacon. All right. Anything else we're waiting on, or is that it for right now? I still don't have a good way to monitor both Twitch chat and YouTube chat. And if anyone has any tips on that, I'd be very interested in it. Not that there's anyone in Twitch at the moment, but just in case. I feel like that's happened a couple times and I've just completely ignored the people that have been in Twitch chat because I just haven't, I just don't look there. And so, yeah. All right. So multiboot V2, let's, maybe we just begin by reading a little bit about what multiboot V2 is. Yeah, pop up Twitch chat besides YouTube. Yeah, I have this like janky, weird ass setup on my separate monitor, but like as I kind of change windows and like go back in Chrome, and like things get kind of in and out of focus. So I could probably make something better, but it's just like kind of messy. All right, so maybe just a brief recap of how multiboot V1 works, though, before we dive into multiboot V2. So brief recap is, okay. Earlier on, for our OS, we used a custom bootloader. It's all this like stuff in boot.s. It's a completely custom bootloader. I did not write it. It's probably the simplest bootloader possible, and it's a master boot record bootloader, which is like legacy technology, like legacy BIOS, and it doesn't do like anything except like load the kernel. So that's one way of doing it. Another way of doing it is not rolling the bootloader yourself. Another way of doing it is using an existing bootloader, like a existing, like widely used bootloader. And grub is an example of one of those bootloaders that's super industrial strength, widely tested, deployed like all over the world. We can use grub, and what that means is that, so first of all, none of this boot assembly and stuff is relevant anymore. It's totally unused. And that means is now our kernel needs to somehow integrate against grub in order to be loaded by grub. And so basically there's this kind of contract between the OS and the bootloader. And that contract is called the multiboot specification, because grub is an implementation of this thing called the multiboot specification. And the specific parts of what that contract means, it's not actually that much. It's just a couple things. So first off, you need to specify like a magic number. For multiboot V1, it's this bad boot thing. You need to like have this magic number somewhere in the kernel, in like your kernel, and then that is how you communicate to the bootloader that you conform to the multiboot spec. and it's like actually kind of a very basic setup. The reason that you have this kind of weird header or weird magic number thing is actually because with multiboot, it's designed to be able to support arbitrary executable formats. And so it's designed so that if there's like all these executable formats in the world, they don't want to like add support for all of them to grub. They want grub to be this universal thing. And so they've designed this way where rather than grub like checking the magic bytes of the file or something, kernels that want to be booted by grub advertise this with like this magic number. In practice, I think no one really uses that functionality. I think in practice, most people just use elf files, which grub does know how to load. But that was part of the original design goal of multiboot, is that they wanted it to be agnostic of the executable format, which means, of course, that grub won't be able to kind of like actually granularly like load the executable because it can't parse it. But what it can do is basically just like copy it into memory somewhere and then pass control to something. So that's kind of interesting historical tidbit, but basically that's what it looks like. So you put these magic bytes in there, and then what that means is that it tells grub that you are ready to be booted by it, and then grub is going to do its thing. And maybe I have screenshots already there. Then there's like a whole bunch of guarantees that grub gives you. I guess I don't have it screenshotted right here, but it just guarantees you all sorts of stuff about like the state of registers on entry. It guarantees that you'll be in 32-bit protected mode. It guarantees like all this like stuff. And apparently it's already time for a 20-second break, so I'll do that and be right back. All right, but yeah, and also of particular interest, it guarantees that the EBX register EBX is going to contain a pointer to this structure that we were looking at earlier. It's this big structure with a lot of useful information. And that's the specific part of the multiboot standards, that EBX points to this thing. So what we can do in our kernel entry code is after, like in our particular case, we enable paging, and that's mostly it. And then before we jump into the C code, we push EBX, and that allows us to just do this nice thing where now we can receive this thing as a pointer in our C code. You could have a Twitch bot that repeats all the YouTube messages. That's how I see most people do it. Interesting. Twitch bot. And so those messages would go into the Twitch chat, if I understand. All the YouTube messages go into the Twitch chat. Interesting. Good idea. Maybe I could check that out. Yeah, shout out to the 1 or 2 viewers in Twitch right now. I see you. Appreciate you being here. All right, so that's a brief recap of multiboot v1. And as a little bit of a proof of concept of this, I just made the OS print out the command line field, which is part of the info struct that you get from grub. Because one of the many features of grub, one of the many nice things is that you now have support for a kernel command line. We did not have support for this at all in the previous version of the OS because the bootloader didn't do that. But now, since we're integrating against a more like professional bootloader, it gives us nice features like a kernel command line. So let's just maybe, before I go further, I will try to just demo that. Does this? Yes, and so that all happened kind of fast, but it booted the OS. This message comes from grub, booting my hobby OS, and then these log lines are from the kernel, and we can see command line arg1, and that is coming from grub config dot whatever. So basically this is like a config file that gets packaged up into the boot image. So then grub boots up, reads this config file, and then determines what to do. I think I'm gonna comment this timeout thing out, because I was a little bit surprised that it booted so fast. Ah, dang, okay. Now I cannot manually, okay, now I need to go to my kern make frag, and as a dependency I need to add this grub config to the dependence. Now when I modify the grub config, it'll rebuild the boot image. And now we can see the boot menu, which kind of waits for a certain timeout. And I had it previously enabled, so it didn't do this, because I disabled the timeout or something like this. But now there's a certain timeout where you can actually interact with the boot menu, and you can do stuff like pass command line arguments to the kernel, and that's why we see arg1 when the OS boots up. So that's just a bit of a proof of concept about how we got multiboot v1 working. Okay, so now it's time to delete some or all of that code, and begin with multiboot version 2. And I feel like I'm gonna try to do this without ChatGPT, without AI, and just see how far I can get, just kind of like doing some raw manual reading. But who knows, maybe it's difficult. But in my experience, these multi-boot specs have been pretty short, pretty understandable. So yeah. Digitalize, this is really cool. I feel like booting is one of the more opaque processes that occur in the kernel. Yeah, absolutely, definitely. A lot of that stuff is very, very witchcraft-like. But it's also, booting is also an interesting topic because it's something you run into even if you're just trying Linux for the first time with zero technical knowledge. You are flashing an ISO and stuff like this with grub on it probably, and you're interacting with a lot of these things. They just have no idea how they actually work. And so I really enjoy this part of OS dev because it allows you to learn about this very fundamental part of how computers work, which is how they turn on, basically. So, quick overview of the table of contents here. I've not read this at all yet, so I don't know what's in here. Yeah. Just another quick side note, another great benefit of not using our own bootloader and using grub is that it will make supporting UEFI a lot easier, from what I understand. Because I think we are still currently using legacy BIOS booting. Even though we're using grub, we're just using grub's support for legacy BIOS booting. But that's also not very modern or like professional or like cutting edge or anything like that. It's like incredibly old technology. And so eventually I would like to port us over to like the more modern standards like UEFI. And the nice thing about targeting grub with our OS is that I think we shouldn't actually need to make very many changes, like if at all, to port to UEFI, because grub supports EFI, and so you can set grub to be your bootloader when you're booting with EFI, and then the interface for the OS is exactly the same as it would be for master boot record BIOS booting. And so that's just another benefit of using something like grub. And yeah, like people are talking about like the Limine bootloader these days. It's probably also super good. It's maybe even better than grub. I don't know. All I know is that grub is super industrial strength, like used in production. The Limine bootloader, as far as I understand, is just used by like hobby OS developers. And so that makes it slightly less interesting to me, because if I learn grub, I might actually be able to use this like in a job or like in the real world or something. I think that's a little bit less true for Limine potentially. So that's kind of why I'm using grub. Okay. Anyway, so there's a lot of info here. The exact definitions, blah, 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 blah. Yeah, multiboot v1 also was extremely x86 specific. Now with multiboot v2, it has better support for different architectures and also 64-bit. So multiboot v1 doesn't support 64-bit at all. Examples. Example OS code. It's pretty nice that they include this. Okay, so multiboot 2. So I'm just gonna go ahead and copy this. All right, I think I can't copy out of the PDF exactly, so I'll hop over to this part. I am pretty confident we're going to need this, so I'm just going to multiboot 2. Okay, we got our multiboot 2.h. Yeah. You know, let's just quickly skim through what they're saying here. Background information. Blah, blah, blah. This is all just kind of like the basic motivation behind multiboot. I think none of this is particularly interesting. This, I think this section explains the motivation behind the like magic number. Okay, boot modules, we don't really care. Okay, so that was already the first section, so it's not really that long. Yo, Cat Black, what is up? What's up, Cat? Dang. I hope that message wasn't from like super long in the past. I have a hard time managing my YouTube chat and my Twitch chat, but nice seeing you. Yes, that's an Ableton shirt. Yes, big fan of Ableton. Yes. Yeah, nice seeing you. Thanks for joining the stream. Yeah, everyone in the stream, follow Cat Black on Twitch. She's a really, really cool artist. All right. Yeah, so anyway, back to this thing. The exact definitions. The layout, okay, so this is the first key piece of info that we're going to need, the layout of the multiboot 2 header. I'm just gonna screenshot that. So multiboot v1 was pretty simple, just like a magic number, some flags, and then the end thing. Multiboot v2 is a little bit more complicated. Magic, architecture, header length, checksum, and tags. Okay, so we can get off to a little bit of a start with this. So first off, we have this nice magic number we're gonna need. Love some magic numbers. And we're putting all this into entry.s. Yeah. Okay. Architecture. Zero means 32-bit x86, so that sounds like what we want. Okay, so we're going to add, you know, maybe I can make this easier and split screen this. Dang. All right. So we're back here. So we're going to have multiboot architecture. Header length, including so the tags are required. And maybe we just read a little bit through. So header length, length of the header, including magic fields. The length checksum is some value when added to the other magic fields must have a 32-bit unsigned sum of 0. Tags constitute a buffer of structures following each other, padded when necessary in order for each tag to start at an 8-byte aligned address. Terminated by a tag of type 0 and size 8. Okay, this is interesting. Sorry, just check in stream health and all that. But hello to the 10 people on YouTube. All right, So tags. So apparently there's like tags. Type, flags, size. Type has two parts. Lower is an ID of contents of the rest of the tag. Size contains the size of tag including header. If bit 0 of flags is set, the bootloader may ignore this tag if it lacks the relevant support. Yeah, I'm kind of glad I didn't start out with multiboot version 2. This is significantly more this is, I don't know if significantly, but it's quite a bit more complex than V1. There's like a million tags. Okay, how do I? Complexity seeming to arise from being more agnostic to the underlying architecture. I think that's one thing. I think also it's just it's compatibility. They're trying to have much more robust support for, like, if you have a very new operating system that uses a bunch of new multi-boot features, but it's running on an old multi-boot V2 bootloader that doesn't support a lot of them, or like different combinations of this, or it's like a super old OS running on a super new bootloader. And so that's why they have this tag thing. And also that that required flag is, I believe it's in support of compatibility. So what I am looking for right now is like, what's the minimal, like the minimal amount of header I can have. Boot information. Upon entry, EBX contains physical address of a structure. Basic tags structure. Boot command line. This tag indicates which BIOS disk device. Wait, no, I want boot. Oh, command line. Type 1 string. So this is what I'm interested in. That's going to be my proof of concept. And was that already 20 minutes? All right, be right back. This is interesting. What's up, coders? Lo-Fi Station. As anti-malware kernel driver in Windows, how can I detect or find out unsigned kernel drivers which are manually mapper with mapper like KD mapper? I have no idea. Straight up, I have zero clue. Yeah, unfortunately not your guy for that in any way. But maybe someone else in the chat knows things about that. Yeah, unfortunately, yeah, not really my wheelhouse. Let's take a look at this example OS. Oh, interesting. We can even potentially use these constants. Okay. Boot.s. You are working on Windows kernel drivers? No, nope, not even a little bit. Never written a Windows kernel driver in my life, unfortunately. Wait, this thing just goes off the screen. Dang. Where's my HTML version of this? Okay. So magic, architecture, header length, checksum, is it for Linux? Nope. This is for like a custom OS. So no Linux involved here. Multiboot header end is probably some symbol there. Check some. It's just okay. It's just this value, and then if not defined elf, and so that doesn't apply to us because we are an elf file. So then we have a couple tags. So it seems what you do here is in your header you specify some tags about I don't know, the services you want or something like this. It probably explains this. Anyway, so just out of curiosity, then what does the C code look like? So in C, we receive a magic number and this pointer thing because they probably push probably push EBX and EAX. And they do a magic number check. And then they I don't know. They start parsing some tags. And apparently this adder thing contains a size and then a little bit after it points to a tag or contains a tag. No, is a pointer to a tag. And tag is what? Multiboot tag. And then there's this kind of iteration through the tags. And what is going on? It's the most convoluted thing. It is some kind of like linked list looking thing, maybe. multiboot uint 8 tag plus tag size plus 7. And with so this is zeroing out some bits at the end. To make it 8-byte aligned or whatever. Okay. And then it's like handling a bunch of tags. Okay. What is interesting though is this example OS is handling a bunch of these tags like command line and bootloader name and I don't know what else. But for example, with command line, I don't see that requested here. Which kind of makes me think that it's automatic or something. Let me see. All right, let's get back into this. Let's maybe we can skim to find a bit more info. No, I don't think any of this is relevant. Okay, let's really apply our brains here. What's up, Moose? How's your day going so far? It's going great. Thank you for asking. Yeah, had a great Saturday so far. Got out a little bit this morning, did some exercise, and now I'm doing OS development. So it's an awesome day. How's your day going? Okay, but this is kind of interesting. But I feel like I'm learning things here. So okay. We already saw this. Tags required. So that's all easy. That's easy. General tag structure. Type flags size. And then there's like random data after. What's that all about? So you can set the bit to mark it as optional. If you don't do that, then what? Bootloader may ignore this tag. Otherwise, what happens? Does the bootloader like fail to load the OS or something like this? Or is there an error? Okay. So this is type 1, type 2, so the address tag. So in each tag, there's this header, and then there's some random data specific to the tag after, it seems. But then it mentioned there is this padding requirement. And so you might have a bunch of arbitrary data, but things need to get padded to an 8-byte alignment. So we have this like these chunks of data. But buffer of structures following each other. This is interesting. Type is divided into two parts. Lower contains an ID for contents of the rest of the tag. And then it just doesn't talk about what's in the upper part, if I'm reading this right, so that's kind of confusing. If this tag is present and optional is set to 0, the bootloader must support the requested tag. If the bootloader does not understand the meaning, it must fail with an error. However, if it supports a tag, but the info conveyed by it is not available, bootloader does not provide and passes control. So if it supports it, but like couldn't get the data, it just doesn't include the tag in the information structure. Okay. Okay, so let me see. So the example OS included if not elf, then the address. So this is what we're seeing. So if you're writing a non-elf operating system and you want it to be booted by a multiboot 2 bootloader, you need to have an address tag, I believe, because that's how you specify the information about where you want your very exotic OS image to be loaded. So this is not relevant for me, I think. I think this is also not relevant. Entry address. Again, that's only relevant if you're not using like elf and you're using something weird. Okay, I don't know. Flags. Okay, so I don't know. I scanned through all these tags, and wait. But command line was pretty early, right? Command line was like, or was it? Interesting. So command line is down here in the boot information. Then it has a section about machine state. And this is kind of what I'm talking about, was like all the guarantees you can expect about the system. Okay. I don't know. Upon entry, EBX contains the physical address of a multiboot to information structure. Let's just see if we can find I'm just curious what that looks like. Multiboot header is this thing. They helpfully give you a bunch of C structs. Okay, I don't easily see this anywhere here. Okay, basic tags. Boot information consists of a fixed part and a series of tags. Its start is 8 byte aligned. Fixed part, total size, reserved. So this is that thing we were seeing here, where I take the address, dereference it to get a size, and then bump +8 to point to something after it. Total size of the boot information, including this field and terminating tag in bytes. I'd never seen that sort of bit operation before with that tag size byte aligned around, so I spent 5 minutes proving to myself why it works. Cool. I did not prove to myself why that works, so I will ask you if I have questions. I just hoped it works. But yeah. Yeah, what the hell? It like adds 7 and then like rounds it down to a multiple of 8 or something. Oh wait, tag, so it has the pointer to a tag. And then there's the tag size, which might, I guess, which might not be 8 byte aligned. And so to ensure they reach the next, to ensure they properly hit the next 8 byte alignment, they add some number and then like mask it back down. And I guess 7, and then for some reason 7 is like the number you use for that or something. Okay, 20-second break. Feel free to join me for a stand up and stretch. Okay. Every tag begins with the following. Yeah, adding 7 first guarantees that it rounds up instead of rounding down. Yeah, I see. Yeah. It's a fast way of sealing the tag size. Yeah. Okay, so anyway, so maybe I will also begin a brief diagram of my understanding of this thing. So we have the multi-boot header over here, but then it also seems like there's this multi-boot info struct. The thing over here is what, as an OS, you give to the bootloader. the thing on the right is what you receive. And every tag begins with the following fields: type and size. Not including padding. Tags following each other padded. So this is exactly the same thing as what it said earlier here with tags. So one thing I'm like not really getting is the relationship between a tag over here in the header and a tag over there in the data, but maybe I actually do get it. So with the tag, you can specify some information to the bootloader about like a feature you need or a thing you need from it, and you can actually pass information to it. And that's this like variable length part of the structure. And then a similar thing comes back to what I didn't quite get is like, let's say I just want the command line. I want to use the command line functionality of multiboot 2. Do I need to specify that somewhere in my multiboot header? So far, so there's no command line tag in this header section. But if we zoom down to the boot information section, that's different. There's a lot more stuff here, including a tag for the boot command line, which strangely is of type 1. Why is it so... like, why didn't they put it first then? Okay, that's like weird to me. Every tag begins here. Okay, I think I roughly understand that. Okay, I'm just going to YOLO it, I think. I'm just going to try to make a multi-boot header, and I'm not going to pass the command line. Maybe. And also, interestingly, the string is just inline in this blob, so... yeah. Okay, let's just try making a super basic multi-boot header. Well, we can even do it based off of this thing here. So I'm just going to get my code up here, and let's just give this a try. Entry.s. So, so this thing made use of some like assembly labels. That seems kind of useful. I wonder... it does this interesting thing where it actually puts the multi-boot header into like the code section, and it has a jump instruction to jump over the multi-boot header and not accidentally execute it. And I don't actually know enough about like assembly syntax, but I kind of like currently I'm not doing that. I just declare it before the actual code, but it would be nice to have some like boot header. Can I even do that? I literally don't even know. Maybe compiling will tell me. If I exclude the colon, does it syntax fail? Yes, okay. So it seems like I can do that, which is cool. So we have the header, And then we're going to have some end header. And I'm just going to put this here. End header for them is it's just the place after the last tag. So looking good. And then so now I can do .long header end minus header. Okay. And then flags is no longer really a thing. But then we have this like super long line for the checksum, which I will just inline that right here. And I'll just get rid of this thing. I mean, it would be kind of cool to actually be able to use the actual header file. Let's see if we can do that. So kern multiboot 2. So theoretically I'm just going to comment this out. Okay, so now it is failing because it tried to include a bunch of C into my assembly file. And they had this one particular way of working around that, but I think that doesn't work for me. But the good news is this is not the first time we're dealing with a header file that's included from assembly. Also, what's up, Michal? Thanks for joining. Long time no see. Good luck implementing multiboot 2. It is really low level stuff. Not really that complicated, but you really need to follow the convention. Got it. Yeah. Yeah, I think we're getting there. I'm getting my understanding around it, but it's definitely a lot more complicated than multiboot 1. So for example, with mmu.h, that's also this like header file. Oh, and then so it's this assembler thing. That's the way, for whatever reason, we do this here. So I can, yeah, just do this. So now this should actually compile. If not def assembler. Okay, so now it's actually compiled. That's kind of cool. So now we can use some of these nice like structs or types and stuff. So it's like multiboot 2 header magic and multiboot architecture i386, for example. Oh dang. Where's the i386? 0, right? That's what we want. I'm just going to clear out some of these tabs. And then this thing, and then now this thing is going to work. Okay, so we're getting there. I was just curious, Michal, if you're still here. Have you implemented multiboot 2 before? You seemed like you knew some stuff about it. Okay, so far, so good. Now it's time to Now it's time. I'm just not going to add any tags and just see what happens. So now it's time to go into our init.c. And now we need to change like a bunch of stuff. All of this will need to change. And also this will need to change. That is fuzzy search. I don't. That's unfortunate. There's a super good VS Code extension. Fuzzy search in file or something like that. Install. All right, I'm not gonna do that. All right. So I don't see like a C structure actually for, like strangely, they don't provide a C structure for this like initial part. Maybe it's not needed, but I might just add my own just for fun. And so it's going to look something like struct multiboot. What do they call it? Boot information. Not implemented, but looked at quite a number of implementations. Read a lot of code along the years, decades. Nice. Yep. Okay. So I find it a little bit odd that, yeah, there's no struct that corresponds to this, unless I was just not looking carefully enough. But so here we have this big section for all the header tags, right? And we're not interested in header tags. Multiboot tag, no, but that's also not right. Yeah, okay, I think our new type is going to belong here. For whatever reason, they just didn't give us a struct. Maybe they thought it was too trivial. It's like the boot info header. And it's just going to be this, and it's going to be total size, total ris, total size, and reserved. And then now we can make this multiboot boot info. Oh shit, I need to change this to be multiboot 2. So now this is a, I don't know, let's call it P header, let's say. And why? Because I didn't add like a type def. Something like that. Multi-boot boot header info T. Okay. So tiny little bit of progress. So now we're just going to get, and what does it have? It has the total size of the boot information. Okay. And it's a uint32t. Right, I might just add an assert p header. Okay. So we get the total size. And you know what? I'm just going to add a function that's just like void parse multiboot to tags. And I'm just going to pass in it doesn't really matter because we're just kind of doing experimental code right now, but parse multiboot to tags p header. Implementing C structs in assembly is kind of voodoo. Easy to make errors. Yes, very easy to make errors. In fact, I'm just going to double check because you said that. So total size, I mean, I just kind of copied it because this thing came first. But the confusing thing is that with all these diagrams, it like lists the struct members. In memory, it's like kind of flipped. If you have a pointer to this thing comes first in memory, then this thing. And it's also like that here, like this thing will come first in memory, then this. So I believe I got it right. I think just naively copying this, but yeah. Okay, so we get the total info size, and so I'll just panic after parse label 2. Okay. So we're gonna have a just nice controlled got total size. Does this compile? Oh, what the? Are you seeing this? What is that error? Cannot resolve. Zero. Holy. That might be the best error. Like, we've seen quite a few interesting errors, but can't resolve 0 abs section minus L0 und section. Holy crap. I think that's something here with the subtraction. If I comment this out, does it build? If I comment this out, does it build? Yes. Seems like the second section is in the wrong section. Second section is in the wrong section. Second label, multiboot header, end. Let's bring those things. So this thing. So actually, this thing. It's just this line, right? It's this specific checksum line. Yeah, abs versus und. What can I do about this? I can always. So I actually have no idea what this warm boot thing. I have literally no clue what that does, but I can always do it the way that they did it in the reference code. Where they, you know what, I am, I'm gonna make use of my Copilot subscription and ask AI. I should be, you know, okay. How do I add context? I want to add this line to the context. I got this error when compiling. How can I fix it? Let's see if Copilot knows assembly. Okay. Copilot does not know assembly. That is completely the wrong. That is the wrong answer. It's definitely, it's Michael. I believe you're right. It's something to do with. Header must be in the first code segment. Can't resolve. I'll love it. It's not. 20-second break time. All right. Be right back. Okay, 39, right? 39 cannot resolve these. Yeah, the struct is, well, actually, I do think the struct is in the text segment. Glob entry. It is having a problem with this expression, I think. Did I copy paste this correctly? I didn't actually take the time to really understand what this does. It just computes like that number to make everything like equal 0 or something. It computes the sum of these things and then makes it negative. So I did multiboot header end, right? Multiboot header. What about a different model? What's the best coding model these days? I'm just gonna ask this. It's some problem with some labels like header end. Question for chat, is anyone using AI tools for coding, like Copilot or Cursor, or even just like ChatGPT and stuff? I'm trying to get into it a bit more. Wait, so okay, ChatGPT also does not know what it's doing, because maybe it doesn't have enough context. If I added the multiboot 2 for the third time, I'm going to copy and paste to give it the context. it's really yeah, no, it is really getting tripped up about these constants, and that is completely not the problem. What is the easiest solution here? I think the easiest solution is to go full multi-boot and to do it the way that they did in their example, which is to what? So they have the start symbol, start, followed by a jump. So we're going to actual entry. We're just gonna go and align 8. Interesting. I need to be, okay, that's good to know. I'm gonna, there's no way that fixes it right now. So we're just gonna go and copy this directly into our code. I'm just gonna get rid of this warm boot thing, which I don't understand. I don't think it's necessary. Actually, no, this thing is aligned like this. And then now we just need a jump actual entry. And let's try. Holy crap, that still didn't fix it. I was not expecting that. Just, okay. Can't resolve. Oh my god. Abs. It's this thing, right? Yeah. I think it is mandatory start code with some minimal code. Jump multi-boot entry. I'm just gonna Google this. Actually, no, I'm just gonna Google this. Not that I really expect to find anything. Okay, no. Okay, look, I think we're on our own. Oh, why is this not working? This is the stupidest error ever. Just to really nail it down a little bit more specifically, if I copy this line, but I just delete that subtraction part, I would expect that this, oh. So what's the problem here? Is it this? Was it that variable? Yeah, it's something. Oh wait, no. Wait. Okay, no, it was I think AI was right, actually, guys. Sorry, AI. Grub, this grub thing is actually just not defined. All right, I'm going to, yep, so I'm cooked. I'm officially cooked. When the AI revolution happens, I'm I'll be the first one to go. Yeah, when the AI world takeover happens. Okay. Stupid, man. Wow, what a insane error. I'm gonna screenshot that just for the memories. You type in something that doesn't exist and tells you that. Okay, let's get back to the fun stuff. So 61. And I had this print statement here, so that's gotta go. Okay. All right, we're going. We are moving. So now I'm just gonna run Kimu, and no multiboot header found. You need to load the kernel first. So that clearly didn't work. You know, there's like some tools. I'm just gonna ask again, what tool can I use to verify that my OS has a valid multi-boot to header? There's like some grub tool that I used last time. Grub file. Okay, let's try grub. i6 grub file. There we go. Kernel. If the file is compliant, the command will exit with status 0. And it exited with 1. But I'm interested in, okay, yeah, multiboot 2, so we need a 2 there. And 0. Oh, I know the problem. I know the problem. Now we also need to make sure to edit the grub config and say multiboot 2 instead of multiboot 1. That will do it. All right, let's go. Wow. So now I'm not quite sure what's going on, but I think it's failing to load the kernel for some reason. What could be happening there? So I'm just gonna panic, like panic. Okay, so, okay, that's a good sign actually. So we actually did get kernel execution. But I have like no code running. Like what? P header. Right. Was this a null pointer by some strange chance? No. Okay. Oh, I think I know. It's like virtual physical memory stuff. What's contains the physical address. Okay, I forgot that key part. So this thing is a physical address. Which means phys adder t. Phys adder. And then I'm just going to convert that into kadder, p phys adder. And now we convert that into a kernel virtual address, which we can work with. Now I think things should work. Let's go. kadder called invalid PA. That is annoying. If I recall correctly, that wasn't like a real problem. That happened last time. And it's just because n pages didn't get, there's like this assertion in this function to make sure you're not trying to translate a physical address that's out of range of physical memory, but the variable where we detect memory doesn't get populated until later. So we can't call kadder like this. So how did this work? Yo, what's up, RA6? Also, what's up, Marcus? We are slowly inching our way forward to getting the OS to be booted by grub with the multiboot 2 standard. Something allowed this to keep working. I think so technically this code was using physical addresses, but actually physical memory is mapped at this part, and so it is possible to access those low memory addresses, and I think that's just what was going on there. Okay, so here's what we're going to do. We're going to move this down after mem init. But I also remember getting super messed up because some of these, the kernel includes some of these unit test type things which run, and the unit test actually clobbers memory. It writes 97s all over I don't know, like memory actually, which actually wrecks a lot of, it like corrupts all of the stuff we would be looking at actually. So I'm just going to disable these unit tests. That was kind of painful from last time. Okay, so now I just happened to remember that, but now, so now we're after mem init, so memory has been detected, and we should be able to run some code. Let's try it. Oh, okay. This is the key thing that needs to happen after mem init. We cannot call kaddr. Ooh. So that is interesting. Kind of unfortunate that we couldn't see what happened there. Wait, no way. Something's going badly. I wonder if it's these check functions again. So I'm just gonna go into mem init. Yeah. Detect memory. Check. I have a sneaking suspicion that these check functions are sort of like messing with stuff. Tragic. What? I just want to see. Something is going horribly wrong. Okay. Panicking after mem init is not working. What could be the reason for that? What could be the reason for that? All I did was comment out some of these check pages. I don't think that should have any effects, but just to check, I'm just going to drop that. I'm just going to, actually I'm just going to stash staged changes. So now we have the checks back. The checks should not do anything. Holy crap. Taking away the checks. Like, oh my gosh. Mem init initializes virtual memory. When the kernel gets initial execution, it uses an extremely minimal virtual memory setup. And then mem init kind of actually creates the more production virtual memory setup in terms of the address space. If I comment this out, are you telling me that what is going on here? This is just supposed to be some kind of consistency check. There should be absolutely no side effects. If this runs, I guess also I will change the grub file and put this back in so we don't have to hit enter every time. Okay. Yeah, okay. That is actually insane that this needs to run. N-free base mem. Please tell me that's a local variable. Okay. All it does is just assert stuff. The only thing it sort of kind of does is this weird memset thing. If I remove that, are you telling me that that breaks things? So that worked. So now if check page free list. So what happens now? That is the most bonkers thing ever. Somehow there is something important happening here. Page free list. Yeah, this is actually the worst part of this kind of work. This thing is not even interesting. I think it's... Okay, well, it is kind of crazy that this actually matters. So I'm going to add this back, and I'm just going to slowly comment things out until I understand, until something breaks, basically. So this is expected to work. That works. And that does it. It's somehow important for this. Move pages with lower addresses first in the, wait, what? I never actually understood. Move pages with lower addresses first in the field since entry page does not map. Crazy. Okay. So in that case, just to move forward, I'm going to comment out this weird place that like corrupts memory for the tests. Okay. So now that that's fixed, let's just run it. We got a 1, 2, 3 panic, which I believe happened here. All right. Okay. Got size negative, blah, 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 blah. So something is weird here. So first of all, I'm printing it as a signed int. That number is still way too big. I'm also going to ask, what's the printf format specifier for unsigned int? It's U, right? Almost certainly. Yep. Okay. So that number looks way too high. Let's just see that in hex. That is an address. That's what that is. So what did I do wrong? What? Somehow we got an address here. P total size contains a pointer. So we receive a physical address. Can I have multiple panes? Show. You know what? I think it might be time to whip out the debugger. I think it's 6 init. Okay. Fizz header. So right, so that looks like a physical address. Mem init runs. P header. Right? Can I do this? Interesting. Okay, so something is so messed up. So I think the code is right, but for some reason this pointer is like super, it's pointing to like something extremely odd in memory. I don't even know what these are. Two, 8. Did I mess this up somehow? Okay, maybe there's something, maybe I overwrote the memory with mem in it somehow. So my theory is that the bootloader had some data in memory. And then when we called mem_init, which initialized our virtual memory setup with page tables and stuff. I mean, actually, this sort of looks like page table entries in some kind of odd way. But I'm thinking we accidentally overwrote the part of memory where all that boot info was. Which is kind of unfortunate. So I'm going to, out of desperation, reach for another hack. Detect memory. I'm just going to call this function out here. And it's time for a 20-second break to stand up and stretch. Be right back. Yeah, it's unfortunate how many roadblocks are in the way constantly. Okay, so let's move this back up. And so we do this, which means kadder will now work, which means we also don't need to do it here. Which means, and then because this thing comes later, I think it's not going to overwrite all this bootloader memory or something like this, because what mem_init does is it boot alloc. There's this function called boot alloc. No, boot alloc. Then page init, and this is what initializes this memory allocator, which starts like dishing out physical memory. And I'm pretty sure this thing is not aware of the page of memory where all this bootloader information is. And so it was offering this up as free memory. And then people were like writing to that memory because the memory allocator returned it. And so I think that if I had to guess, that would be the original, that was like the actual problem. And so we're just making sure to do all this stuff before we call mem_init. And so I would finally expect and hope that this would actually work. Oh, input, oh dang. So now of course this function is not available here because it's static and void. So time to just make it public. pmap.h, we're just gonna add it literally anywhere? Actually, you know what? Where is mem init? I'll add it right here. Okay. Marcus, what kind of editor or tool is that where files, branches, commits, and stash? This is called lazy git. It is a terminal git client, and it's great. It's really good. Okay, finally, check this out. We finally got it. That is a much more reasonable number. Yeah, a lot of stuff just kind of getting in the way of us to get there, but we finally got there. That's awesome. So now we're finally set up to parse the multiboot 2 tags. And I'm even thinking of creating a new file for this. Doesn't really matter that much, but it's conceptually a separate like module of code. But I guess I won't do that for now. We're just kind of sketching out how this will look. So now we can boot 2. So now we got our tag, multiboot, tag. Current tag. And yeah, there's no type def for some reason for any of these. Was there also no type def in the example code? Also no type def for the example code. So we need a struct. And actually it's going to point to p header plus size of p header. So I'm just doing this based off of the description here. So it says boot information consists of a fixed part and then tags. So we had the fixed part. Fixed part is super simple. It's just 2 things, total size and reserved. And then I'm just trying to find where it specifies that things are all packed together. I actually don't see it. Tags are followed one another padded. Yeah, okay. Wait a sec. Okay, I don't know. It specified somewhere that the tags come directly after. But we can just see that here in the code, like adder tag equals adder plus 8. Yeah. So Mr. Maker, David, for your packaging, thank you. Appreciate that. So they just hard coded an 8 here, but 8 is that's basically the same thing that I did. So I'm just gonna try to not look at that example code too much if I can help it. And just try to parse this thing based off of my knowledge about how to do this. And so so we get a current tag. and there's going to be an end tag. So that's probably the most important thing to watch out for. So we need to have a loop. And what's the end? I'm just going to do a while one to sketch it out because that seems to make sense. So now we need to check for tag type. So it's going to be uint32t type. Actually, do we give u32? No, we don't. Equals current tag type. And then we're going to switch on the type. And then case multiboot tag last. Or no, what was the tags are terminated by a tag of type 0 and size 8. So tag type end. Okay. Break. But actually, no. I want to like exit iteration of this whole thing. Okay, I'm just gonna have my bool should stop equals false. What's up, devoid dude? Also, what's up, tree? Do I need a, oh. So it should stop. Okay. Multiboot tag just above the while one are allocating memory there. No memory allocation going on. That's just setting a pointer to the initial, it kind of points to the first tag structure, which we'll be processing. So we have like an array of tags, and we just need to point to the first one. All the memory is allocated by the bootloader, which allocated some memory, put a bunch of data in there, and then passed us a pointer to that block of data. So we handle, and then now we need to set tag equal to, and then here's that weird thing where we need to do tag pointer t tag plus tag, what was it? Oh, it's current tag. Maybe I'll just call this cur. Plus cur size plus 7 and then mat and something like that. I didn't just that was based off of the example code, I have to admit. So that was based off of this thing right here. So we take a tag address plus plus the tag size to get to the end of the tag. And we need to also make sure it's padded to 8 bytes. And so we then bump it another 7 and then mask it down 7 bits to make sure we padded it correctly. Printf cur. I'm just gonna print out cur each time. Just also assert cur and 8. Just assert that p cur. Cur is a multiple of 8. 0. Right. And technically it was saying that the size is equal to 8. I don't know. Technically size should be equal to 8. But I don't know what we're supposed to do if the size wasn't equal to 8. That's sort of like weird. We could assert that, but also we might not want to crash the OS just because we observe that. So it might be better to warn on that or something. Yeah, I'm just gonna do could check that size equals 8. So this is just a nice little attempt at doing this. Peaker, so peaker plus size plus 7, and then I'm just going to cast this back to struct multiboot tag. Is there a problem? This expression must have integral type. Okay, there's a couple issues, so bummer. So multiboot tag. The first one should go away, and then now it's saying invalid operations to binary blah. Okay, so again with the casting rules. So that worked. Let's run it. I forgot, as usual, I forgot my, sorry. I forgot my, why, oops. Okay. All right, check that out. That's cool. We got a lot of tags actually. Known tag type. That's kind of cool. done with parsing tags. So I would call that a bit of a success. We successfully received the multiboot information block, and then we're able to parse through and iterate through its tags, which it gave us. And I'm gonna take out this print just so we can see. So let's just see what we got. We got 21, 1, 2, 10, 6, 9, 4, blah, blah, blah. Just out of curiosity, what do we... Also, damn, I missed the Twitch chat. What's up, EDU, 21 Faria? What you're doing is impressive, brother. Thank you. I do not get caught up in macro hell. I try, sometimes I do, but it just hasn't really come up. Thanks, Miho. Yeah, it's me, Kevin. What's up? Damn, nice script of code. You must be experienced as IT guy and love your job. Yeah, I would say I like my job. My job is not doing this, but I like computers a lot. Spend a bunch of time programming them. Just out of curiosity, how? Okay. Let's take a look at what tags we got. Also, just taking a quick break to look at how the stream is doing. 18 people in the stream on YouTube. That's awesome. Thanks for being here. And 1/0 on Twitch as usual. What can I do to get more Twitch viewers? That's the real question. All right, whatever. So let's just look at what kind of tags we have here. So the interesting thing is that we didn't even we didn't explicitly request any tags. In our multiboot header, it just ended. Like we didn't give any additional information. And yet we got a bunch of stuff back from the bootloader. So that's kind of cool. What's up, Ahmed? Damn, the first time I catch a Mark live. Well, it's great to have you. Appreciate you being here. Yeah, so let's just take a look around. 21. Interesting that comes first. Image load base physical address. What? Okay, now I'm getting suspicious. Why did we get a 21? It is provided only if image has relocatable header tag. And we did not provide a relocatable header tag by any means. So that is extremely odd that we're seeing this. But I'm just going to ignore that. So next one would be 1, and I think that's the one we're actually interested in. That's the boot command line. So that's super exciting. We could even try to just parse that. I'm feeling lucky. So command line. And so now what do we do? Now we multi-boot. Why did okay, why is it not command line? What, they don't provide? No way. This like header file is pretty half done, if you're asking me. How do they not tag string? I guess that is the one. Tag string, but why? equals pcur p command line tag. So now we can be a bit more specific about the thing that we're pointing to. So originally it's just this pcur thing, which is the most generic kind of tag. It's just the generic multiboot tag, which refers to the start. Now that we've identified that the tag type is command line, we can like customize it a bit more for the command line, which is like a string, and C style 0 terminated UTF-8 string. So that means this should be as easy as got command line, and then we print a string, and then we just say p command line tag string. And I think that is it. Let's check it out. This will be so cool if this works. It did not compile. I need to cast it, I guess. Dang, that is cumbersome. And check that out. That's awesome. Got command line arg1, and that means we could pass other command lines if we wanted to. So that's very cool. I'm stoked about that. I'm so stoked that I think it's time for an air horn. All right. Let me check just to make sure it's not too loud. So, oops. So. Is that audible? It's kind of quiet. Ah, there we go. Yep. So, yeah. What else? So let's keep going. What other things do we see there? 2. Name of the bootloader. Type bootloader name. All right. Bootloader name, grub 2.2. That's sick. So we're really able to like receive information from the bootloader. That's super cool. Bootloader name. What else? 10. APM table. What could that possibly be? Advanced power management. Oh, did not want to click that link. APM. I think that is a obsolete standard. If I remember correctly, it's like ACPI, I think, is the newer one. 6. That was memory map. That's cool. So now this thing has a bunch of, it's like a variable length structure, and internally it has a bunch of these entries. And that's actually awesome, because otherwise it's always been kind of a question to me of like what memory regions are available in physical RAM. Currently there's a lot of hard-coded assumptions about this, I believe, in page init. It's just like, we just have all these hard-coded addresses of like, okay, the multiprocessing code Azure is not available, and like the IO FISMEM region is special, and blah blah blah. So I think that's one of the major benefits of using like a production bootloader, is it can actually detect memory and pass that off to the OS. What's the stuff you're reading about? Boot info, a PDF. So this is the multiboot 2 specification. And it's the document that tells you how to make your operating system bootable by grub, basically. If you want to have your OS to be booted by grub, you need to follow this. It's the V2 spec. There's also a V1, which I did in like last week's stream or 2 weeks ago. But then this is V2, which is a bit more modern. Yes, so that's super interesting. Entries. All right, I think there's a typo in this document. Base address is the starting physical address. Length is the length in bytes. Type is the... All right, 20-second break. Be right back. Okay. And okay, this is interesting. 1 is available RAM, 3 ACPI, 4 reserved, which needs to be preserved on hibernation, 5 occupied by defective RAM, and all other values indicate a reserved area. The regions occupied by kernel, MBI segments, and modules. Okay. 6, what about 9? Elf symbols. This is kind of interesting. So, section header table from an ELF kernel, they correspond to something, yeah, in the ELF header, or section header entries. All sections are loaded in the physical address fields refer to where the sections are in memory. Yeah, so that's kind of cool. So in case you were in case the kernel was interested in its own section headers and stuff, it could use this information. Alternatively, it could just like try to parse itself by, I guess that's a good question. How do you how would you find the start address of the kernel? I think we do this with a linker script. If we go to pmap.c, because we also reserve, okay, no, that's just a constant. So we just hard coded actually. I think it actually is in the linker script. Here we go. Yeah. So this is what determines where the kernel gets loaded, and we just rely that this number is the same as this other number, this one. Okay, so nothing too special. Anyway, so 9 is all that elf stuff. 4, what's 4? Flags tag. And bit 0 said at least one of supported consoles must be present and information about it must be available in MBI. Okay, some random flags. Type 5. Frame buffer tag. Okay, this is some graphics stuff. So as the preferred graphics mode. If this tag is present, bootloader assumes the payload has frame buffer support. Contains the number of columns, the number of lines, bits per pixel. Cat Flare, what is up? Nice to see you. We're doing a bit of multiboot today. Multiboot version 2. Not sure how, if you've implemented that in your OS, but it's been pretty fun. So frame buffer information tag 8. Module alignment. Type equals 8. Frame buffer info. So there's multiple frame buffer tags, it seems. Frame buffer info contains frame buffer physical address. This field is 64-bit wide, but bootloader should set it under 4 gig if possible for compatibility. Right, I forgot. Yeah, you are a Limine user. That's cool. I wonder how different Limine and multiboot version 2 are, because I think they're both tag-based protocols. But yeah, everyone has good feedback for Limine. Okay, some frame buffer info. That was 8. 14. ACPI old RSDP. I have no idea. This tag contains a copy of RSDP. Who knows what that is? Okay. So that's cool. Not sure if there's really anything more I wanted to do. What's up, Bernardo? I want to get into this type of dev. What resources I need to start? I will link you to my resources page. To do operating system development, you should have a good understanding of C, and a bit of assembly, I would say. But yeah, there's a lot of good courses out there you can follow, and tutorials and stuff. In Limine, you can get certain structures like frame buffer memory by creating a structure with an ID, revision, and response pointer. Limine looks in data sections specific IDs and fill them. Interesting. So you don't even need to parse things, I suppose. It like writes to your OS's memory, I guess. That's kind of cool. Sounds convenient. Yeah, currently I just have this parsing loop. kind of bad parsing loop. All right, so okay, then in entry.s, technically we don't need any of this anymore. This is good, and this is the change we want, so that's good. Grub config. It's multiboot 2 now, and yeah, we probably could convert this to a for loop, I suppose. It's going to be kind of a crazy for loop. And the stop condition is what? If cur type equals 0. So to start out, we set our pcur at some place. We technically don't need this case at this point. And then just checks if the type is not 0. And I messed it up. Oh, wait, what's up with the while one? Okay, crazy. It was doing a while one with the for. Okay. There we go. Maybe that's a little bit nicer than the while one. We don't have this should stop thing. That's a little bit. I guess we don't really need the total boot. I guess, yeah, I don't really know what the purpose of this total boot info size. What do they use it for? I think it doesn't look like they use it at all, really. So it's just like something you can get in case you care about how much data there is for some reason. But I mean, maybe you could use it to guard against like a weird, let's say there was a bootloader bug where it actually didn't give you the end tag ever. And so for a naive implementation like mine, the kernel is just going to it's just going to parse like forever basically, because it just never finds the end tag. And that's kind of bad. And so with the size, what you could do is you could have like a check. It would be, I guess, right here. And I guess like end is going to be wait, what is including this field? So it's p header plus boot info total size. And what's the error? Oh, p header. So we're able to get the end of the data block and say, and so in our loop, while the p cur is not 0 and p cur is less than p end, iterate. So now that's slightly safer, and we're just guarding against weird we need to cast yeah, so now we're just being extra careful. We're just checking in case there was a weird bug, so we just don't loop for like ever throughout memory. The maximum we're gonna go with our iteration is to the endpoint of the data block as determined by this size member. Nice one. So I would call that a success. And I would call that a good stopping point. So that's going to be multiboot 2 support. Basic multiboot 2 support. Cool. All right. Yeah. Just curious. No one on Twitch still. Very interesting. I wonder how I get Twitch viewers. Or maybe just Twitch is not into operating systems development. That would be unfortunate, but whatever. But cheers and thanks to the 17 people in the YouTube chat. I'm gonna end the stream here. I'll just self-promote myself quickly. I have a Discord channel. If you feel like hanging out on Discord, how do I post this? Store chat. Discord channel. Yeah, please subscribe to my channel if you like what I'm doing. I do this every week. Another operating systems topic or video every single week. And yeah, I think that's pretty much it. So so just to recap, we basically implemented basic support for multiboot 2, which allows us to boot with grub and get a lot of useful information and be on the more recent multiboot standard. Yeah, and doing that involves, in the OS, you need to change the multiboot header to the multiboot 2 boot 2 header, but it's still pretty simple, not much to it. The bigger change is the data that the bootloader passes to the OS. It's in a totally different format. And it's not just a simple structure, but it's this array of tagged elements. And you can iterate through these tags and extract pieces of information that your operating system is prepared to process. So in our case, we're parsing out the bootloader name and the command line. And just see that here, command line arg1, grub 2.12. And that command line argument just comes from grub.config right here. Nice. So yeah, that's it for today's stream. Thanks a lot for joining, and I'll catch you next time. Peace.